So here is the second new operation that is appropriate for vector fields. It is called the curl. And in a visual sense for vector field, the curl has indications of how rotation works or doesn't work, especially in a three-dimensional sense. So again, the purpose of this video isn't the physics or visual aspect of the vector field. It is merely the computation. Sorry to disappoint others. So if we have a vector field in 3 dimensions and 3 variables, each component of the vector has as many as 3 variables in it, x, y, and z. Then it turns out the curl of a vector field needs to have a 3-component answer, even if your original vector field only has 2. The way it's measured through a literal formula is the p components y partial derivative minus the n components z partial derivative. And you can see there are 2 other similarly confusing items. M with respect to z minus p with respect to x. And then finally, you can see here, if you only have x and y variables, they end up, especially in the z component of our final answer, n with respect to x minus m with respect to y. Now, if this looks a little familiar to you, it might be because it's very much related to a cross product calculation. So this is a short notation that our textbooks and some others use almost as if it was a formula. I would not call this a formula unless you already understood it. It's a reminder of a shortcut. If you're new to the calculation, this is an actual formula to plug into. And let me scroll up a little bit, so to speak. If it were a cross product, we could look at it this way. I, j, and k components, and the gradient would refer to the various partial derivatives in order. And then our vector field f, m, n, and p. And you could look at this as when you do the determinant of a matrix, and we use this method, expansion by minors. There's this little shortcut. So, to find the x component, it's the p with respect to y, which was the first term here, minus n with respect to z, which is, that's here. If we were to continue using the method expansion by minors, there's a connection between cross product and this formula here. Not everybody computes a determinant this way. Some use other techniques. There's more than one way to write the matrix out, and there are always formulas. Anyway, this is our formula. So let's test it on an actual example. There we go. Now it's on the screen. So we've got a vector field, x cubed z, comma 4xz, comma negative 3yz. And we're going to compute this vector called the curl of the vector field. The y partial derivative of this component, remember, this is m, this is n, and this is p here. The y partial derivative of that looks to be negative 3z minus the n components z derivative would be, well, that's right, 4x. middle term, middle component, m with respect to z would be x cubed minus p with respect to x would be, that's right, 0. Two more derivatives, one more component. N with respect to x would be 4z minus m with respect to y would be 0. And when the dust settles, negative 3z minus 4x, comma x cubed, comma 4z. Now, if we were given coordinates of a point, for example, we could find the curl of f at the coordinates 1, 2, 3. What we'd be doing is trying to find out something related to, at this point in space, a value that describes its rotation, more or less. For this problem, negative 9 minus 4 would be negative 13. 1 cubed is 1. 4 times 3 is 12. This would be a numerical vector. We will mostly be interested in using this later in the chapter. One more piece of information. Remember, you have a pause button. You can slow me down. Hard to do it live, but it's possible in recordings. One more piece of information here I'd like to share with you. If these look strangely familiar to you, but you can't quite put, your mind on what that was, if I were to set this equal to 0 and rewrite it and do the same here and the same here, this was the same as the test for a conservative vector field. So it turns out that if you were to end up with all three components equal to 0, so if the curl of f is the 0 vector, then f was conservative. The term for this, in the sense of curl, is that it is irrotational. We will not have any applications in our class for this, but in the physics sense, I think there are definitely groups of people that are interested. So there you have it. Curl of a vector field.